Okay, so we've got an example to do with friction and statics. So a mass of 8 kilograms rests on a rough horizontal plane. The mass may be modelled as a particle, and the coefficient of friction between the mass and the plane is 0.5. Find the magnitude of the maximum force P, which acts on this mass without causing it to move, if A, the force P is horizontal, and B, a separate question, the force P acts at an angle of 60 degrees above the horizontal. Okay, so first of all, this bit where it's saying about the maximum force P which acts on this mass. So the maximum force acting without causing it to move, that's telling us that at that point we've reached the maximum friction. So that is really telling us that in this question we're using F equals mu r rather than F is equal to or less than mu r. Okay, so part A, if we draw a nice diagram of what's going on, we've got the particle, which I'm representing as a block here. We're applying a force to it. The other forces acting on it will obviously be its own weight, which is going to be 8g, and reaction force, and the friction. Okay, so we're going to have to resolve horizontally and vertically, and then we're able to find P from there. So if we resolve vertically, straight away that's going to tell us that R take 8g is equal to 0. So because it's in equilibrium, it's not actually moving, and therefore R is equal to 8g newtons. So because it's not moving, we look at the maximum force, it's not moving, it's on the point of moving in effect. We have, so as the block is on the point of moving, we know that because we've got the maximum possible force for P. We know that the friction force is equal to mu r. So we were told that coefficient of friction is 0.5. We worked out r to be 8g, so that's 4g. And then if we resolve horizontally, we'll find that P subtract F equals 0. So therefore P equals F. So P is 4g, or 39.2 newtons. Okay, so the second part's going to be a bit more complicated because we're now acting an angle above the horizontal. So let's move that out of the way. Draw another diagram. It's going to look pretty similar. So we have the box again, the particle. So we'll have the friction force still got a weight of 8g, still got a reaction force. It's going to be slightly different this time because this force P is actually pulling it up slightly, so the reaction force is going to be reduced a little bit. So an angle of 60 degrees there. So first I'm going to break P into its components. So vertical is P sine 60, horizontal is P cos 60. Then we're going to resolve forces. So if we resolve vertically, I've now got R add P sine 60 subtract 8g equals 0. So in other words, R is equal to 8g subtract P sine 60. And sine 60 is root 3 over 2, so 8g subtract root 3 over 2p. And then because we're talking about the maximum value of P, we know that F will be equal to mu r again. So that's 0.5 times by 8g minus root 3 over 2p. Or if we like, we make that 4g subtract root 3 over 4p. And then we're going to resolve horizontally. So resolving horizontally, P cos 60 subtract F equals 0. So therefore P cos 60 is equal to F. Cos 60 is a half, so that's half P is equal to, and we worked out F to be this a moment ago. So 4g subtract root 3 over 4p. And then we just want to solve there to find P. So we're going to have half P plus root 3 over 4p is equal to 4g. Then that left hand side, in fact, if we just calculate that's a decimal, so we're going to give our answer as a decimal anyway. So we want to do a half plus root 3 over 4. So that left hand side comes to 0.933012719p is equal to 4g. So we just need to divide by 0.933, etc. Okay, so I get P is 42.0 newtons from there, and then that's our answer.